All right, hopefully you did all right in this warm-up. Let's take a look at it. So for number one, we are looking, really both of these, we're looking to find these equations in standard form. And thankfully for this first one, it's pretty simple. So looking at it here, we got to have the x and y on the same side in order to be standard form for a conic. So this one, all you need to do is just add 9 to both sides. And remember, we don't want any coefficients in front of x or y either. There aren't any, so we're good there. If there were some coefficients, then we'd want to divide by 9 on both sides at this point. And we don't have that, so we're good. This is it. That is our equation in standard form. And again, since there's no fractions here, it's not an ellipse or hyperbola. And then we've got two things that are being squared, so it's not a parabola. So this is a circle. For number 2, same idea, but this time we do have a coefficient in front of y squared. So we need to take care of that. And the constant's already moved over to the right, so all we need to do is divide everything by 4. So x squared over 4 is just going to stay x squared over 4. Minus the 4 and 4, it's going to make a 1, so it's going to be y squared. We can put that over 1. And that's equal to 1, because 4 divided by 4 is 1. So this is our standard form equation. This is since it's got the fractions, it's either an ellipse or a hyperbola, and since it's minus, it's a hyperbola. And there we go. So today we're going to be taking a look at solving systems of equations. And we did this in the beginning of the year, but those were just with lines. Just 2 lines, and that's it. And today we're going to take a look at it if we have conic sections or any type of function at all. So we can bring in anything we've seen this year, absolute value functions, quadratics, which again would just be a parabola like we have already within conics. But it could be any of the conic sections. It can be a line. It could be an absolute value. It could be a log, exponential, radical, rational, all kinds of things, right? We've seen a lot of things this year. So this first example, so our first graph there, if we were to graph it, we're not going to graph these to start. We're going to start graphing it for number 2, because that's going to make that one a little bit easier. This one, though, it's not too bad as it is, because we have this second problem, or second equation, equation 2, where we can just move the y over to the other side. And we have solved it for x. And now we can use substitution to solve for y. So we're going to substitute this equation, this binomial for x, into the first equation. So 4 times 2 minus 2y squared minus 16y squared equal to 25. And you might be thinking, oh man, we have a y squared, that's going to make things harder to solve, but it's not that bad, I promise. So first thing we have to do, though, is square this binomial. And squaring binomials, remember there's that cheat. So we square the first term. 2 squared is 4. We multiply the 2 terms together. So negative 2y times 2 is negative 4y. And then we double that, so that's a negative 8y. And then we square the second term. Negative 2y squared is a positive 4y squared. And all that minus the 16y squared still equal to 25. So now we need to distribute the 4 into the parentheses, into all 3 terms. So that's going to get us 4 times 4 is 16. 4 times negative 8y is negative 32y. And 4 times 4y squared is going to be 16y squared. So now hopefully you're noticing that we have 2 16y squares, but one's positive, one's negative, so they are going to cancel each other out. So the y squareds go away. Got a simpler equation to solve now. So 16 minus 32, that's an ugly 3. 32y equal to 25. And now we just need to solve this 2-step linear equation. So we're going to subtract 16 from both sides. So we have a negative 32y equal to 25 minus 16 is a positive 9. And we divide by negative 32 on both sides. We're going to get an ugly fraction out as our answer, but at least the work was not super complicated. So it's negative 9 30-seconds. So that's our y value. We need to find x still. So remember, the solution to a system of equations is a point, or in this case, and really with all of these problems, whenever you're looking at linear, nonlinear, or even two nonlinear equations together, we could have situations where we have more than one solution, or we can still have no solution. So we could have no solution, we could have one solution, we could have two solutions, we could have four solutions. It'd be really strange if you end up with three solutions. It's not impossible. It would be strange. But typically 0, 1, 2, or 4. That's what you're going to come across. If you have 3, then you had a polynomial in there that did something strange. But it's not impossible. Or some other function. Depends on what you got. So now what we're going to do is take this y, and we're going to substitute it in for y in that blue equation we did first when we moved the 2y over. So we got x equal to 2 minus 2 times this negative 9 30-seconds. And we got to deal with some adding and subtracting fractions. Unfortunately, it's what it is. But 2 in 30 seconds is going to be 64 30-seconds. Now we might be able to simplify the ending fraction, so keep that in mind, but we'll see. So negative 2 times a negative 9, that's going to be positive 18. So it's plus a fraction now. So now when we add these up, 64 plus 18 is 82. And for sure we can simplify this because 82 and 32 are both divisible by 2 at the very least. So x is equal to 41 over 16. And that's about as far as we're going to go with simplification. So our solution is the point with these two as our ordered pair. At 41 16ths, negative 9 30-seconds. And yeah, we could get them as decimals. We don't need to. That's totally fine as those fractions. So kind of ugly. And I'm going to tell you now, a lot of these end up being pretty ugly. But some of the graphs and things really have some different situations happening that make it kind of cool. So our next one is probably the most complicated problem we have here because it's a real-world example and it takes into account a lot of different things that we've seen this year. So distance formula is going to come back in a little bit, and then we got to deal with converting something, and so there's a lot going on in this real-world problem we're about to see. So Rosetta enters a highway 10 miles north and 12 miles west of the service tower for a radio station. I don't know why station's capitalized. Whatever. She follows a straight path and leaves the highway 25 miles south and 8 miles east of the tower. If she averages 70 miles per hour and the range of the station is 15 miles, for how many minutes will she be in the range of the station when she's on the highway? So she is entering a highway. She's driving straight down a line, and she enters into the service radius for this radio station. We're going to say the radio station's at the origin. Makes our lives a little bit easier when coming up with the equation for the circle then. And we need to come up with the points that she is entering and exiting the highway. So she enters the highway at 10 miles north, so that's our y in the positive. 12 miles west, that's to the left, so that's a negative for our x value. So she enters the highway at negative 12:10. She exits the highway 25 miles south, so that's a negative 25 for the y. And 8 miles east, that's now to the right of our axis, so that's a positive 8. So there's our ordered pairs for when she enters and exits the highway. That's not when she enters and exits the radio station's service area, but we do need those in order to come up with the equation for her line she's traveling down this highway. So we're going to use our slope formula. So yeah, we got to bring back slope in this one too. Remember, that's y2 minus y1 over x2 minus x1. So y2, that can be either the negative 25 or the 10. Doesn't matter which one's which. We'll do the negative 25 and minus 10 over. Our x2 then has to be the 8. And minus negative 12, since we're subtracting a negative, we are adding. So across the top, negative 25 minus 10 is a negative 35. 8 plus 12 is 20. And this simplifies, because 5 goes into both, to a negative 7/4. So there's our slope. Now we need to come up with the equation for her line on the highway. So we're going to use point slope form. So y minus y1 equal to m times x minus x1. So y minus, it doesn't matter which point we use, because it'll give us the answer no matter what. So we'll just use the first point there, y value of 10. Our slope is negative 7/4 times x minus our x1 is negative 12, so we're adding 12. So first thing we need to do is distribute that negative 7/4 into the parentheses. So we get negative 7 over 4x minus, so negative times a positive is negative. 7 times 12 is 84. 84 is divisible by 4, so that comes out nice and pretty to be 21. So minus 21. And now we need to move that 10 over, so we're going to add 10 to both sides. So we have y is equal to a negative 7/4 x minus 11. So there's our first equation. That's her line on the highway. Now we need to figure out the equation for the circle that is the area that the radio station covers. That one's fairly simple. The center, let me do this in blue. Center for the radio station is at 0, 0. And we know our radius is 15 miles. So remember the base form for that is x minus h squared plus y minus k squared equal to r squared. Again, hk is 0, so that just is x squared plus y squared. And our r squared, that's 15 squared. We can leave it as 15 squared, but 15 squared is 225. So now we have our equation for our circle. We have our equation for our line. We have our system of equations to solve. I'm going to tell you right now, it is extremely complicated to solve this by hand because you end up with a quadratic. You have a lot of things to deal with. We're not going to do that. We're going to go ahead and pop this into the calculator on Desmos. So give me just a moment to pull that up. All right, so let's take a look at Desmos here. So we're going to go ahead and plug these in. So we have x squared plus y squared equal to 225. So now it's not even on my graph, but if I zoom out, there it is. And then we have the line to graph. Y equal to a negative 7/4. X minus 11. Change these to the colors I wrote in. Not that that really matters, but that's okay. So there's our radius of the radio station. There's her driving down the highway. We can put the points that she enters if we wanted to, but it's not a big deal. If we wanted to do that, we could actually just limit where this line is from negative 25 to 10 in the y. Nope, I did that backwards. Well, anyway, it doesn't matter. So the main thing we're looking for is where this line crosses, and we have those points here and here. So we got them on our graph done for us. We don't have to solve the system of equations by hand. It's already done. So we're good there. So now we need to go ahead and write these points down. So I'm going to write them down real fast here. We got one point at negative 11.67, 1 point at the x value, and then the y value 9.423. We have another point at 2.194 and negative 14.839. So now what we need to do is use these to find the distance that she was on the highway for. So we're going to use our distance formula. So the distance is equal to the square root of x2 minus x1 squared plus y2 minus 1 squared. This is why we refreshed our memory on this from algebra prior to doing the conics that we did at the beginning of this unit. So plugging in our numbers here for the points we just got. Make sure I can fit all this into the radical here. So that's going to be our x's. It doesn't matter which order you go in. The advantage for the distance formula here, minus 2.194 squared plus 9.423 minus a negative 14.839, and that's squared. All right, so we got some subtraction to deal with these decimals. Lots going on, but really at this point, the easiest thing to do, since we have all these decimals, is just to plug it in the calculator. And when you do that, square root it at the end, you get 27.94 miles. So that's how long she was on that highway distance-wise. We also know she's going 70 miles per hour. So her speed is 70 miles per hour. Well, we know she went 27 miles, so if we divide our distance by our speed, remember, speed is equal to distance over time. So if we swap time and speed, we'll be able to solve for the time. Now, this is going to give us hours to start, so we need to keep that in mind, and then we'll convert it to minutes after we get that. So our distance was the 27.94 divided by 70. That's going to give us 0.399 hours. We multiply that by 60 to get minutes, and our answer is 23.95 minutes. That's what it asked us to find. So she's on that highway. She'll be able to listen to that radio station for about 24 minutes. Lots of work for that one, right? And we even skipped over some of the work because we used decimals to our advantage. So keep that in mind, that some of these can be very complex. That's where the graphing calculator comes to your advantage. So let's take a look at this next one. So number 3 here, we need to solve the system of equations again, but this one isn't really set up very well for substitution. I guess you could use substitution still, but it's actually set up really nicely to use elimination instead. So if we multiply that first equation by a negative 1, that's going to give us a negative x squared minus y squared equal to negative 16. And now we can just add up our equations like we would normally with elimination. 4x squared minus x squared is 3x squared. Y squared minus y squared eliminates the y squareds. And that's just equal to 23 minus 16, which is 7. So we are going to get an ugly fraction once again, but that's okay. So we need to divide by 3. X squared comes out to be 7/3. And we need to square root both sides, remembering to do plus or minus. That eliminates the square on the left, so x is equal to the square root of 7/3, means we're going to square root both 7 and the 3. It's kind of ugly with that, but we're going to multiply that by square root 3 over 3 because we can't leave a radical on the denominator. So we end up with 7 times 3 is 21. So plus or minus the square root of 21 over 3. And there's our x value. So now we need to use that to find our y value. So we're going to plug that into the first equation, since that's the most simple equation. So that's a plus or minus. At this point, it doesn't make a difference which one we plug in first. So we'll just do the positive 21 thirds squared plus y squared equal to 16. So 21 thirds squared, that's going to cancel the square root on the numerator, and square 3, that's 9. So it's 21 over 9 plus y squared equal to 16. We can simplify that. They're both divisible by 3, so it's 7 thirds plus y squared equal to 16. We need to subtract the 7 thirds over. So we have y squared equal to 16 in thirds is going to be 48 thirds minus 7 thirds, which is going to give us 41 thirds. And again, we're going to have to square root both sides. Again, including plus or minus. So we have y is equal to plus or minus square root of 41 over plus or minus the square root of 3. Again, we're going to multiply by square root 3 over square root 3. And that's going to give us y equal to, so 41 times 3 is 123. So it's plus or minus the square root of 123 over 3. So now we have our, what x could be, either plus or minus that, and what y could be, either plus or minus that. And now we need to come up with the different combinations for our solutions to this. So there's the one where x is positive and y is positive. There's one where x is positive, but y is negative. There's one where x is negative, and y is negative. And then there's one where everything's negative. So these are the 4 solutions to this system of equations. So we have a circle and an ellipse that are intersecting. They're both centered at the origin, and they basically look like this. Or these are the 4 intersections that we just got. So now we're going to shift over to look at systems of equations, systems of inequalities with these same things. So we're going to do this by graphing. It's kind of the only way to really solve these. So the first one there is an inequality with a parabola, since we just have x squared, and it's just being shifted 1 up. Otherwise, it follows the same pattern we always see with these guys. So it starts at 0, 1, goes to the right 1 up 1, to the right 2 up 4, and the same pattern on the left. This is a dotted line, though. Since it is just greater than. And since it is greater than, the shading for it is going to be inside. Since it opens up, it's inside. If it opened down, it would be outside of it. It's kind of weird. Our next one is a circle centered at the origin. Radius is the square root of 9, which is 3. So we go out 3 in all directions. This one's less than or equal to, so we can go ahead and do a solid line. And there's our circle. And it's less than, which means it is shaded inside of the circle. So our solution is everywhere where there's overlap of the shading. And that is everything right here, in this little tiny pocket right here. And including this part of the line for the circle. But not anything outside of that. And there we go. Fairly straightforward for these. Of course, you can graph these on Desmos as well, and it will do the shading for you. Now, it's kind of cheating, right? You want to graph it and see what it looks like by hand sometimes. But either way, on your assignments, you're going to see some that are by hand, so you're going to have to do them by hand, or at least transfer them from the graphing calculator. Got one more of these to take a look at. This one involves an absolute value function. We haven't seen those in a while. But we've got a circle first. Again, it's centered at the origin. This time the radius is the square root of 16, which is 4. I don't know why I set up the graph this way, but it's cut off to the left, off to the right there. But it's all right. It's also a greater than, so it's a dotted line. So there's our dotted line circle, and greater than means everything outside of that circle is going to be shaded. There we go. Now, you have to graph the absolute value. And remember, all this is just like graphing a line. That's x plus 4, but once it gets to where it would be negative, it goes back the other way. Since the plus 4 is inside with the x, that means it's shifted to the left 4. So that means it just crosses the x-axis right on that circle point right there. And then the slope is 1 in front of x, so it's just going to go up to the right. 1 and 1. And to the left, 1 and 1. So there are the points. Again, this one's greater than, so it's a dotted line. And greater than means it's shaded above it, just like the parabola before. Everything that's between it or above it. There. So that means our solution here. Now it keeps going on forever, right? But for our graphing purposes, it's everything outside of the circle and above the blue dotted line. That's up here in purple now. And there we go. So if you have to rewatch this, rewatch it, and get the Edpuzzle video done as well.